So yeah, I will talk about basically having data with many features, so n dimensions in pandas. First, who am I? I'm a researcher in economics, but luckily I didn't study economics since the beginning, and this allowed me to discover Python, which I would have never discovered probably as an economist. I work on social and economic networks. Small ad, if you are curious about analyzing networks from an economic point of view, there's a book coming out in fall. I'm mostly able to do research with open source software. Mostly means when I work alone, because when I work with other economists, it's really not easy. As far as I know, I'm the only user of Python in my department. But fun fact, that should change soon, because when I joined my current department, I said I'm available if you want to teach Python, be it at the undergraduate level. Anyway, I'm happy to do it. But you know, it's complicated to change the course structure, so I never was asked. But then two colleagues asked me, would you just give us a very short introduction, just a couple of hours? I said, okay, we found a time, and then I sent a mail to some colleagues, so if anybody's interested, you can come. And there are 27 people, colleagues and PhD students who are gonna come. So since Wednesday, it should be a better environment. And I'm a Pandas core dev, which is the main reason why I'm here. Not very active lately because of the book and because I'm married, but yeah, I'm trying to recap for the last time. It was not last time. Okay, for the time, inactive time. So, small disclaimer. This talk was not voted, was not accepted in the beginning, and I said, well, fair enough. People have enough of pandas. It's not cool anymore. Now there are cooler things. But then it was, so somebody, I don't know, declined. And I was giving this lot. The problem was the program was for a 3 hours training, so I won't be able to do everything I wrote in the program. I will try to cover a bit of everything, not going very deep in the details. So what is pandas? Most of you probably know, but let's just spend 3 minutes. Clarifying what we're talking about. Is probably the Python library for data manipulation and analysis. It's basically our way. When I said few people use Python, luckily some use R, which is still a pretty good language. R has this data frame since longer than Panda exists, and Pandas was strongly inspired by them. Now, there are good and bad in both, but I think nowadays we have nothing really to envy to R from this point of view. So in practice, Panda is mainly two things. There are structures that are like NumPy arrays, but with labels. And there are many additional utilities. Pandas has a huge API, actually too large, and we'll see some hints of this later. But they do really a lot of useful things when you have to manage labeled data. So, in short, one may say that NumPy is to list as pandas is to dict. You vectorize something like looks like dicts, or better, like nested dictionaries. That is, you don't access with indexes, you access with keys. Now, if you start working with NumPy, probably the first thing you do is to create an array, which is just a stick of data, one dimension. The easiest way to do it's not particularly useful, but just to show an example, you call an NP array, you put some number, and you mean one, you gave a number, but this is actually a vector, a one-dimensional vector. Now, in pandas, this would correspond to creating a series, which is exactly an array with index, with a label. If you increase dimensions, you get to a tablet of data, which is 2 dimensions, and in pandas, it's a data frame. So it's still a very stupid data frame, but this is not just one. It's one in a table of 1 by 1. Now, if you go to 3 dimensions, in NumPy, not much changes. You just have a cube of data. You just tell n 3. Now, this particular cube is not very useful. It's, again, 1 by 1 by 1. Now, if the same in pandas would be pandas panel, but if you try to type it on any decently recent version of Panda, you're going to get a future warning. Panel is going to be deprecated in version 0.25. Now, you can add another dimension, which we can visualize as a stick of cubes. Not much changes in NumPy, while in pandas, there is this panel 4D. And if you call it, you're going to get an attribute error. It's already deprecated. It's not more in the API. And so on and so on. I don't know how to draw n-dimensional data, so I put a nice flower. this is exactly the same. Really, nothing changes in NumPy. And in pandas, what shall we do? There is nothing like this. So to answer this question, and not just to answer why there is nothing for n dimensions, but even to explain why this is being deprecated, which would seem crazy, we'll have to dig a bit more into details. So first, are 2 dimensions enough? Maybe we only work with data with 2 features, I don't know, time and place, and it's enough? No, this is not the point. We all probably, anybody of us who works with data probably has data which are indexed, but many more features than 2. So are pandas devs crazy or just lazy? Again, the answer is no. We'll see that there is an important reason why a panel and 3D panel and 4D panel were dropped. So pandas data structures have a very nice thing. So this is the example of a series. You can think again as an array with an index. Now, an index is an independent object, which you can manipulate, change. We will see some examples individually. So for instance, if you create then a series, when you do s.lock a, you're basically asking the index to find the position corresponding to the a key. Similarly, data frames, which are the tablets of data, have just an index on the rows and an index on the columns. And when you try to access an element, you're going to ask for the element that has a on the rows, b on the columns, and 2 different indexes are doing the work of finding your element and ultimately getting the cell you're interested in. So let's see some quick example. Just because it's a program, there was some quick introduction. So as I said, it's basically vectorization of a dictionary. Well, let's start from a dictionary. These are called several animals. And from this dict, we create a series. This is exactly the same thing, except that it's a pandas object. And if I want to know the call of a bird, I'm just going to say, series, give me the position, the value of bird, only 1 key because it's 1-dimensional, and I get bird. Now, if I have another attribute, which is, for instance, the weight, I'm going to now create a data frame which has call and weight, and these are going to be 2 columns. OK? So again, now there is an index, which is the same as before. But there's another index that tells me the different columns, different types of data I have. And there are, again, 2 independent objects. And now, if I want a single number, I'm going to have to say the row and the column. So if you knew Python, pandas, that was trivial. If you didn't, you already know pandas a bit. Now, the nice thing is that indexes have very, very different. I mean, there are a lot of different things, objects, instances that you can plug in place of an index. For instance, you have indexes which are specialized for numbers. You have indexes that are specialized for stuff having to do with time. And this is something in which pandas shines. There are indexes of very different kinds, like indexes defining intervals between 2 numbers. But what we are mostly interested here is a multi-index. What is a multi-index? It's a combination of different indexes on a same dimension. So it's not about having more dimensions or considering together rows and columns. It's really one index on one dimension, but with multiple levels. So the idea is that you index going through multiple levels of this multi-index. Let's see an example. So here I'm interested in data which is indexed by some time of the day, some day, and some place. So again, 3 is more than 2. A data frame is not enough with regular indices. So if you look at it, it's something like this, which is not very helpful, but it's much more clear if we transform it in a list. It's basically done the combination of all possible levels in each of these levels. These are 3 levels, and they give rise to these combinations. Now I can create a series indexed by this, and now each row is indexed by some day, some moment of the day, some place, and this is the value. Now this is, if you know NumPy, if you use at least a bit NumPy, this is very, very similar in terms of usage, because for instance I can slice in the sense that I can get just all the rows corresponding to yesterday on the first, and this is trivial, but I can also obviously look at a specific cell, which is in this case is just defined by the row, or I can do partial indexing with many different combinations. I can, for instance, select the first level, take anything on the second, and select anything on the third. And so that's just a simple example of multi-index. And this multi-index allows me to take a one-dimensional structure, the series, and actually index it through 3 different features, which would be dimensions if you want conceptually. But here, they don't change the structure of the data. OK. What do we gain or lose compared to, for instance, the panel we had before in pandas? Well, we still have, but it's been deprecated. It's much simpler to implement. It's much simpler both to write code that makes this type of data work, and both use it. You don't have to remember strange conventions about the axis. You just have 1 or 2-dimensional objects, and it's much easier to remember. They're very flexible. We'll see some example of this. Operations can be much more intuitive. We'll also see some examples. And it's very efficient if you have unbalanced data. Now, the examples I showed before, it is balanced in the sense that for any choice of the first, second, and third level, you have some value. But this is not necessarily true. For instance, in my field, social economic data, it's almost never true. You very often have that some labels go with some other labels, not all. So let's see an example. I have this very stupid chunk of quotes for stocks of 3 known companies. I want to index them, and the natural thing to do here is to index them by time. So when the stock had this value, which firm are we looking at, and bid and ask are, in a market, there's the price that is offered and the price that is asked. So let's index them. And now, with this command, I have basically explained pandas I want to use as index, time, and ticker, which is a natural thing to do, at least a meaningful thing to do. And now I can access any cell by specifying the time. This is very poorly done, okay, because this is time and pandas is able to interpret it. But here I made it very simple. We just have a string which is a time and a string which is a ticker. Now and here already you see that it's not balanced in the sense that, for instance, for this time you have that both stocks were observed, but for some reason for this other point of time, only Apple was observed, not Google, not Microsoft. So this is unbalanced. You could store this in sort of 3-dimensional structure, but it's more like this. It's more like some cells are filled, some are actually not used. So already, if you store them like here, you're wasting a lot of space. A lot, depending on the amount of space and on the kind of data, but can be a lot of space. And this is particularly clear when you have hierarchical labels. So for instance, if I build a multi-index, which is indexing data on both region and province, which you might think is not very wise, but believe me for 1 second, it can make sense. Again, it's not very nice to see, but when we use it to create a series, now, clearly, Ancona is only in Marche. It's not in Umbria and Toscana. So it would make no sense to assume that each province appears in each region. It's actually the opposite. And so in this case, it's particularly wasteful to assume that each feature must have a dimension, and I mean a dimension in how the data is structured in memory. So in this case, it's particularly wise to use multi-indexes and not wise to actually shape the data as if these were independent features. Now one may say, but this is unneeded. This is already a unique index, and so why should I ever need to structure this as a multi-index? Well, there are two main answers. The first is this can be just useful to handle data. The second is between the two extreme examples I've shown of hierarchical data and fully balanced data, there are a lot of possible cases. And this is why I said that pandas is more flexible. You don't have to think about whether you necessarily have balanced data or whether your data will be of this kind. And in many cases, at least in my job, I often have some labels which are more or less balanced. I mean, data is balanced on some labels, but not on others. And you can use multi-indexes for both. Now, what is the bad side of this? It's completely inefficient if there is only balanced data. So I was thinking about the example of MRI data. You have these cubes of brain, which are just cubes. So there, the obvious approach is, probably you don't even need labels, but if you need the labels, the obvious approach is to use, and I will show what. But very often in social data, for instance, you don't have perfectly balanced data. The other con is semantics can be more complex. It's a trade-off. Let's see an example. So far with multi-index, I showed you a series. Let's see a data frame. So this was a series. Let's now look at it as a data frame. Now there is bid and ask, okay? Now, if I want to access a specific cell, now I'm going to have to say, I want this time, this ticker, this column. Now, if we were working with NumPy, for instance, it would be just a tuple of 3 indexes. And even if we were working with a series with a multi-index with 3 levels. Here it's slightly more complicated. You have to use a tuple to tell pandas that you want access to this on the row, and then separately this key, but it could be also a tuple to tell pandas that you want access a given column. But that's it, mostly. Sometimes it's ambiguous. You just have to remember that in face of doubt, be very explicit. So for instance, this is clearly explicit because pandas sees 2 things. This is for sure the rows. This is for sure the columns. And while, for instance, if I write already this, pandas might not be very sure, at least you might not be very sure of whether I'm looking at this on the rows and taking all columns, or at least on the rows and at least on the column. The answer is the previous. So pandas prioritizes the multi-index if there's multi-index on the index. But it can be annoying to guess. So if you're just not sure what's happening, then here instead you're sure. You're doing the same thing, but explicitly saying this is looking at the rows, this is looking at the columns, and I want all the columns. So yeah, the syntax can be a bit more cumbersome, but as long as you get used to the conventions, it's not. The other important convention which I never cease to repeat is that tuples are used to describe full keys. So for instance, this is saying that this is a time and this is a ticker, and together they describe a key. If I wanted instead to describe a list of values, so of different keys, I would use lists. So for instance, I could do this. Okay, so this is not trivial because in Python we are used to the fact that tuples and lists are basically different implementations of the same type of structure. Okay, they are very different, but they work the same way. They don't in pandas. If you want to specify pieces of a key, you use tuples. If you want to specify lists of keys, you use lists. But that's more or less all the semantics, new semantics you have to learn. Okay. Yeah, this is what it would have looked like, the previous example. Let me come back to it. So if we had, instead than a data frame, just a series with a multi-index with the 3 levels, it would look like this without the tuples. OK. So one may ask, well, but if I can do everything with a series, indexed with as many levels as I like, so I can place as if I had n dimensions, even with just 1 dimension with a multi-index. Is data frame still needed? So they deprecated the 4D panel. Maybe they can deprecate the data frame too, because I can index anything with a single 1-dimensional structure. The answer is no, probably obviously. The first answer is R has data frames. We must have them too, but this is okay. not so important. More importantly, people are just used to have data in tables, whether you would load from a CSV, from SQL, from HDF, anything. Usually data is in tables, and there's no problem with this, so we have nothing to fix. But there are more conceptual, philosophical reasons, if you want. One is that it's very useful to be able to switch data to labels and vice versa. For instance, Now, in the examples I've shown so far, no, I already shown you an example. So here I was building by hand the index, but this is not what you usually do with data. Typically, you load data which has already something inside, which is to be used as an index, and you use something like this, which has set index. So take a column and transform it to an index level. This is very useful, obviously, and this is possible because you have more than one dimension. But even cooler, having 2 dimensions and having the possibility to place multi-indexes on each of the 2 dimensions, even both, allows us to do very nice manipulations, which would be possible otherwise, but with pandas are particularly intuitive. So, for instance, let's say this is just to give a name to the columns index, because previously it had none. Then I can, so this is a data frame now, which is described on the row by a time and a ticker, and on the column by what? By the kind of thing we're looking at. I might want to transform this, as I've said, in a series with a 3 levels multi-index. Very simpler. Stack means take something which is on the columns and bring it on the rows. So this is exactly the same data, except that now it's only one-dimensional. It's a series. And I have 3 levels describing exactly the same level data, but again, only on the rows. Or I can, on the contrary, remember that and once I have done this, what is on the rows, I can unstack it, that is, bring it from the rows to the columns, and I get another kind of, so it's still the same data. You see that there's some missing data because I changed the structure and this data was not balanced. Missing data would not be there if the data was balanced. And I have the same data in another structure which emphasizes the comparison across different stocks. And this is very useful for taking specific, for applying specific operations. For instance, I might be interested of looking across stocks at the mean for each time and for bid and ask. Okay, and this is just one command. I am saying that I extract time as a dimension, as a pseudo dimension, if you want, and I take the mean over it. Or, and this is the standard time. So let me show what's happening. When I do unstack, I'm transforming the data in a data frame, which has only the ticker here and time and watt on the columns. So when I do the mean, the default is to take the mean on each column. So it's taking the mean on the 3 stocks. But I can also ask it to do the other way. And so it's basically taking the mean across time and across bid and ask on each of the tickers. Now, you might, I don't know if this seems useful. I can guarantee it is, in the sense that this is toy data, but the ability to extract interesting statistics from the data and from unbalanced data, from data with as many features as you like, with only one command, is something that really saves my life every day. There's not just a mean. I could ask to look across time and across stock. This does not make too much sense because I'm mixing the stocks, but I could look at the standard deviation, and it's also very easy. These are operations on the data itself. I can also use this reshaping to combine the data with other data. For instance, this might be my portfolio. I have 10 Google shares, 3 Microsoft shares, and 5 Apple shares. So in order to calculate the value of my portfolio over time, I have to combine the information I have about prices and the information of my portfolio. Not very complicated. I create a series describing my portfolio, and now I just need to multiply it by something that has on the columns the same index. Now, since now my table is this, I basically want to bring ticker on the columns and take out what. And this is what I'm saying. I take out what, and I bring tickers on the column. Result, this is just the value of my portfolio over time, with, again, missing values denoting, I could actually, the meaningful things would be to fill with zeros so that when I don't have any stock, it's basically 0. Okay, now, there might be cases, as I just said, in which you really need n-dimensional index structures, and it's basically when you have perfectly balanced data and you're very interested in the computational, really in the efficiency of arithmetic operations, for instance. Why? Because when NumPy accesses data in an n-dimensional array, it directly knows where to find a given cell with a very simple arithmetic operation, because each dimension has a given shift, let's say. So if you give it 4 coordinates, it immediately can calculate exactly the position in memory. The same is not true for pandas. If you ask pandas for a given combination of keys, it has to go through each index to find the correct position in memory. So long story short, pandas is not, I mean, if you have if you have perfectly balanced data, pandas is not the most efficient way to operate. And yeah, X-array is more similar to NumPy from this point of view. X-array is exactly what pandas decided to drop. That is labeled data structures with as many dimensions you want. And by dimensions, I really mean that the memory structure of data knows about these dimensions. Okay, there are more nice levels. There's a mistake, obviously. There are more nice things you can do with levels, with multi-indexes in pandas. For instance, pandas is very good at doing group by operations and a lot of operations on groups. And here is a very simple example. Let's see again what we are working on, just to remind it. So I might want to look at the mean over a given level. It's something we probably did before already. I just tell group by, use as grouper the level time on the indexes, and it just does this. So it's what I could have done with a stack and stack operation, but it's even quicker. And the same, I could do it on the ticker level. And so I cover also group by, which was in the program of this talk, and how was it? So just a quick comparison, just to finish. So as I said, panel was present in pandas and was very, very buggy. A small ad. If you want to help pandas, it's always help is always welcome. Please contact me. There are bugs of any kind you might want, from the most simple to the more intellectually stimulating. We'll find one for you, and you're very, very, very welcome to help. So panel was dropped because, as I said, it was just a pain to maintain and was really not much used. But let's see for comparison how things would have looked with a panel. First, this constructor is already a bit more complicated because I'm specifying, it could be simpler, but not much simpler. I'm specifying the data, then I'm specifying the data as a list of lists. I'm specifying the items, which is the most important axis you could think as the columns. And there are 2 other dimensions, minor and major axes, so more syntax you had to remember. And here I'm feeding the data from our data we already saw, just to fill this panel. Now, once you fill this panel, how does it look like? In my opinion, not very intuitive. Because again, yeah, it tells you what I plug in. There are 3 dimensions. It's a panel. The first dimension has 2 elements, but you don't even understand from here. The second dimension has, in particular, you see no data here. Okay, there is no data at all. And this has something to do with my difficulty in drawing n-dimensional data. So even 3-dimensional data is not very easy to show to the user. Now, yeah, it's exactly the same thing as before. This is balanced, by the way. So it's if you want, more efficient in this sense. But again, it's not very, very useful to use. And so this is why it was dropped. So even when panel was present, even I, who use very, very frequently data with a lot of features, I never used it. Because using multi-indexes on data frames or series is really, really even just visually much more friendly. So if you want to inspect the data, there's no comparison. Anyway, just for comparison, this was really more similar to NumPy in the sense that you have the 3 axes. You just pass a key for each axis. OK, one more thing. So as I said, if you want, sorry. Yeah, OK. Here, the panel digression is over. Let's come back to our data. So let me show again what we're working on. So it's in front of our eyes. So assume that I want to get all the data for Ask for Google. OK? I can do it like this. It's just not a good example, but just to be on the same page. I could ask first to get the Ask column and then to look in it for Google. But we already know this is not the best way to work, because we could do it with just one call to lock. Now, what does this call look like? In principle, it should be something like this. So on the rows, I want to get anytime Google, because I'm interested in Google, and I want the column, the Ask column. Now, this will not work. Why? Because this is not valid Python syntax. You cannot just place the column wherever you want. This is a bit unfortunate, to be honest. In my code, but I saw other people do similar things. In every time I work with pandas and with multi-features data, I start with this line of code, which is just assigning to WE, which is for whatever, the 2 dots, basically. So it's exactly the same thing. But now it works, because this is an object, and I can just plug it inside a. So it's maybe not really nice, but I couldn't find anything better, and this really does the job. And again, this helps you whenever you have to select every value in a given level, but this level is, for instance, in a multi-index, and so you have to put it in a tuple. You cannot put it in a tuple this, you can put it in a tuple this. It's, in the end, exactly the same thing. OK. So thank you. Thank you to the organizers to believe I could have managed to squeeze a training inside this time. And thank you, Michelangelo, for the index.
Well, thank you, Pietro, a lot. I have just 2 quick announcements before we have some time for the questions. If you're staying at the hotel of your friends stay at the hotel, please do the checkout. Otherwise, the room will explode, and we don't want that. And but I know you can leave some luggage in the reception eventually. But please do that and tell everyone to do that. Another quick thing, so we have Panda stickers in the non-focus booth. We are happy to give it to all of you if you're interested.
If you pick the bag.
Yes, and also about if you want to spend 1 word about the sprints, for example.
Yeah.
And if you want to ask a question, please raise your hand.
So if anybody of you is in Tennessee in July, he's welcome to. No, OK. But OK, it's a possibility. No, but in general, we are very interested in helping people who want to collaborating, and at any level, you can start with the docs if you don't have, if you're afraid you're not able to contribute with code. You can dig in some simple examples. There are some issues which are labeled as easy issue, so you can start from them, but feel free to contact me at any time.
Thanks for the talk. I think I fit your target because I'm an economist starting to use
there are at least 2
Python
of us
right now. And for me, the problem is that I work daily with multi-level panels that can load very easily. The thing is that once you've loaded it, you want to basically estimate variance covariance matrices for standard errors. And in Stata and R, there's like tons of libraries that do that. I'm not sure how that type of analysis translates easily into Python language.
Well, you're lucky because you could have told me very many things you couldn't do in pandas, but covariance, OK, I can't reply easily, but it should not be difficult because you very easily calculate correlation probably instead it's more simpler. like, give me 5 minutes, and I will think about it.
Now, for example, if you have multi-level data, of course you have to use fixed effects and clustering for standard errors for any type of regression, and regressions can easily be very different.
If we get, for instance, about clustering, I should be honest and say I always use Python, often calling R from Python. So I would never try to convince anybody that Python has all the possibilities in terms of estimation that R of theta give you. But the good news is that RPy2 is a library which combines very well Python with R. So I could never stop manipulating my data in Python, but I have no problems passing them to R for a lot of analysis. But the variance covariance metric should be feasible without. I just didn't sleep enough tonight.
We have time for another question. Okay, if you want to add anything, we have a few minutes. Otherwise, thank you so much, Pietro. And there's the contact for a follow-up question, right?
Thank you very much.
Thank you, everyone.